Hey guys, my name is Frank, and this is the Python Programming Video Log. Today I'm covering part 2 of how to make a tile-based platforming game using pure HTML5 and JavaScript. Today's video is going to be on adding a player object to the screen and controlling him with the keyboard. This is a vital component of any game, so stay tuned to find out how it's done. In this video, I'm going to talk about the example program, what it does, and how the program has changed since part 1. Then I'm going to show you the specific code that handles creating the player, controlling him, and drawing everything to the screen. Finally, I'm going to show you my implementation of a fixed time step game loop and how it works. If you have any comments or questions, post them. And if at any point while you're watching this video you get the sensation that you're learning, be sure to support this video with a like. First thing I want to talk about is what this example actually does and how this program has changed since part 1. So all this example does is allow me to place a square which represents my player on the screen and use the keyboard to make him jump up and down. I also added some stuff in for collision detection and to make it look nice, so he changes color on every jump and he leaves a trail. The reason he's leaving a trail is just because I'm filling the background. I'm redrawing the background on every frame of animation with a slightly transparent background. So that's the reason I'm getting that trail. If I was drawing just a plain opaque background, or opaque, I guess some people pronounce it that way. If I was doing that, you wouldn't be able to see that trail behind him. But I thought that was pretty cool. And it kind of helps you visualize what's going on in every frame of animation, because each one of those squares that you see trailing behind him is drawn on one frame of animation. All right, so now that you know what the program does, let's talk about what has changed since part 1. So in part 1, I had defined my 3 different classes: my controller, my display, and my game. I also had my engine class and my main.js file. So all these are updated for part 2. That's why the file name has a O2 after it. The ones from part 1, like engine, I haven't changed since part 1. That has a part 1. So that's my naming convention that I'm using. Really, the only thing that I changed majorly besides the code that went into making the example work was I took the event listeners out of the display and the controller classes. So the key down up actual event handler function that I hand into the add event listener method in my main.js file, I'm actually defining those inside of my main file now. So this would be one that I moved out, the key down up event listener, and the resize event listener, or actually event handlers. That's what these are. So if I come all the way down to the bottom of my main.js file, you can see that I'm adding these event listeners to the window object, and I'm just handing in the methods that I define inside of my main.js file into these event listeners. So that's one of the changes I made. I decided to make that change because I didn't think that my event handling system was really something I wanted to put inside of my individual classes or my individual components. And the reason for that is a lot of times inside of these, I'm going to have to do interactions with multiple components of my game. So for example, the resize component actually needs to handle 2 different components and have them interact. It needs the display component, which handles drawing everything to the screen and all my graphics. And it also takes information from the game component, which has information about my world's height and width and my player location and stuff like that. So that's just a little bit about the example program and what it does, and a few things that have changed since the last part of this series. All right, so now I'm going to talk about how I define the world and the game object, and this is basically going to define the world that my little player square can run around in and jump in, and it's going to define the player itself. That's going to be just the rectangle that defines the player as well as the color, and it's going to handle some collision detection stuff. As you can see, I can't fall through the floor, and I can't jump or walk through the walls. So all of this is going to be handled inside of my game logic. So I'm going to come into the game part 2 file and take a look at my game class. But I'm going to keep it expanded so we could actually look at the code. All right, so the first thing I'm defining in here is a object literal called world. So inside of my game class, I'm going to have access to this world object. And inside of this, I'm just going to have my background color And by the way, this is that transparent color. So if I come in here and I just change this to something like 0, 0, 0, 0, 0, 0, that's going to be the color for black. If I come in there and save it and then refresh my screen, now I'm no longer going to have that trailing graphic behind my player whenever he jumps. But if I come back in here and change it back, Control Z a bunch of times, get rid of that, and save, and come back here, now all of a sudden I get my trailing graphics behind my player whenever he jumps, and it looks like he has just a cool trail of fading graphics behind him. So that's pretty cool, and it's really, really easy to implement. All you got to do is draw this semi-transparent background color to erase your canvas on each frame of animation. So anyway, to get back to the world object, I just want to make a side note of this and how I did that color trailing feature. The world is just going to have everything to do with the world. So friction and gravity are going to be defined here. The player is going to be defined here. Later on, I'm going to define other objects that are going to be in-game objects. They're going to be defined here. The world boundaries, so the height and width of our level, are going to be defined here. If I were to change this, let's say I want to make the height something like 200 and have a really tall screen. If I do that and come here and refresh the screen, now you can see that I have a really, really tall game world, and that looks kind of stupid. So we're going to change it back, save, refresh, and now I'm back to my normal size. But basically, the world object just holds everything to do with the game world, including stuff like collision. So this collide object function is just going to take an object parameter, and for now that's just going to be handled inside of our game loop on every update. And I'm going to pass collide object the player object that we're defining. I'm going to get to that class later, and basically it's just going to test see is the object to the left of 0, so that's going to be the far left of our screen, and is he beyond the right side of the screen, is he above the top of the screen, is he below the bottom of the screen. And it's just going to set him to where he needs to be and handle collision with the boundaries of our rectangular world here. So pretty simple stuff. Everything in this example is actually really basic. Take a look at the source code. I have it linked in the description. Here I have the update function. Now this is actually going to update everything to do with our world. So the player is going to have gravity added to his Y velocity on every frame. This function is going to be called on every frame of animation inside of the game loop. The player has his own update function, and if I come down to the player object down here, we could take a look at it. See what we got here. Update, it just adds his X and Y velocity to his current X and Y position. Go back up, see what else we got here. So we're going to update the player, we're going to add some gravity to his Y velocity, we're going to add friction, or we're going to reduce his X and Y velocities by the amount we defined in friction, which is up here, 0.09. It's just a simple pseudo-physics way to employ friction in your game. Then we have this.collide object, this.player, and this is referring to the world object that we are talking about. So that's a really simple world object. It just governs everything to do with the world, the dimensions, the player, the colors that you're seeing in there. And also in our game class, we have added, or I have added rather, the player, and it's a simple class. It's using dot syntax to kind of add this player class to the game class. And that's kind of just a way to keep things organized and almost like namespaced in there. It's not real namespacing, but by doing this, I'm not going to have a global class called player. Instead, I'm going to have to reference it with game.player like that. So if I have a bunch of classes that I'm throwing into an external context, say your game is going to run on another website and it's going to be part of the global scope of that website, you don't want your classes and stuff to be just floating around with all the other variable names and class names that other developers have defined. So it's good to try to abstract out your own class names and variable names and do stuff like put them into anonymous functions just to keep your code separated from everybody else's code out there on different websites. But anyway, that's besides the point. We define our player class here. He has a color, he has a height, he has a width, He has X and Y velocities. He has a value for jumping to determine whether or not he's jumping and he's in the air or if he's standing on the ground. We also have his X and Y position. And since I'm just being lazy and I'm not loading him in from a level map, I'm just going to define his values all right at the start here when the player object is instantiated with the new operator. So now I go into the prototype and I have a couple different functions that govern how he moves. I have the jump function, basically just says if he's not jumping, then we're going to change the color and we're going to make him jump down here. So pretty simple. This is the code to get a random color, and I'm not really going to go into that, but basically it just makes his color change every time he jumps. Every time I press the up arrow on my keyboard, the jump function is called on the player, and this code runs. Pretty simple. Same thing for the move left and move right functions. These functions are going to be called in my main JavaScript file. I'm going to take a look at that in a second. And all it does is just add half a pixel to his X and Y or X velocity, depending on which button you press. If I press left, I'm going to subtract 0.5 pixels from his X velocity. If I press right on my keyboard, I'm going to add 0.5 pixels to his X velocity. And then finally, that update function, that's just going to add his X and Y velocity to his X and Y locations in the canvas, respectively. So now let's take a look inside of the main.js file and see where all of these are being employed, which is going to be inside of the update function. So the reason I have my update functions all over the place, I have one for my player, I have one for my world, and I have one in my main JavaScript file, is because I'm doing different things inside of all of them, and I want to keep all of my objects as self-contained as possible. So for instance, the player object, his update function is really simple. It just handles stuff that has to do with the player. My world's update function only handles stuff to do with the world. So this.world.update is going to be this function right here. The world's update function only has to do with things inside of the world. The main JavaScript file has an update function that handles the controller as well as the game. So I'm mixing these two major components of my game's logic inside of this one method inside of my main.js file. And that's kind of where I want everything to communicate. I don't want to have those internal references pointing to other components inside of my game. I want all of my code to be very self-contained, and when I have it interact with other components inside of my code, I want it to be in a safe context, kind of like the main.js file. That's where I'm going to do most of my editing. So anyway, I'm getting information from the controller. I'm just saying, is the controller being pressed? Are these keys active on the keyboard? And if so, I'm going to execute a corresponding function on my player object. Finally, I'm going to call game.update, and game.update is going to go ahead and call world.update. World.update is going to call all of this stuff, and that's going to give me these nice cool physics and take care of all my numbers and player position and velocity and whether or not he's colliding. And that's going to take care of all of the physics logic in my game. It's also going to change the player color. All right, so now I just talked about what actually makes the game logic work, and that is, of course, the game class itself stored in the game.o2 file. So now I have to talk about how I'm getting keyboard input and relaying that to the game class so it can actually take that input and do something with it. So I just showed you inside the main file here that I'm conveying the keyboard's input via the controller object to the game object and telling the game object to do something with the player's position, like move left, move right, or jump. And that's all going to happen depending on what the controller object is doing. So let's take a look at the controller class and see how that works. So the controller class just has three objects here, a left, right, and up object. And those objects are going to be controller.buttonInput classes. So let's take a look at the button input class and see what it is. It's really, really simple. All it is an object that has two Boolean values inside of it, one called active and one called down. Now, active is going to hold the virtual state of our button. So I'll get into that in a little bit because it has to do with jumping. And down is going to refer to the physical state of our button on the keyboard. So if I physically press the up key down, down is going to be true. And if I hold that key down, it's going to remain true. The active value, however, is going to depend more on my actual game's logic. So just remember, keep in mind that down refers to the physical state of the button on my keyboard, and that's what that is going to track. And active is just going to track what that value is of my button object inside of my game's code or my game logic. So now that you know what the button input class is, these three objects are going to be button inputs, and this key down up event handler function is going to be called every time I press a key on my keyboard, whether I press it down or it comes back up. This is going to be called. It's going to check to see what the event type is, key down or key up. So when I press a key down on the keyboard, the type's going to be key down. When I release that key, it's going to be key up. And depending on which one it is, it's either going to be true or false. And then I'm just going to use the get input method of my button input class and hand in that down value, which is either going to be true or false. And that's going to look like this. It's just going to say if the key tracker or the button input object, if that currently is down, the state is currently down, or if the state is not equal to whatever we're handing in, then we're going to set active equal to whatever we're handing in. And we're just going to set down equal to whatever we're handing in, because that's going to be the physical state of the button. Pretty simple, maybe not so simple. Take a look at the source code and fiddle around with it, because that's really the best way to get an idea. I'm just here running over everything. I'm trying to get it done quick because this video seems like it's going to go long. I don't want it to go too long, but basically this is a controller class, just takes keyboard input, and I'm adding the event listener for the controller component inside, not my engine, but inside of my main JavaScript file. At the bottom, if I come all the way to the bottom, you can see I'm adding the key down and key up listener to the key down up function, which I'm defining also inside of my main file. And that is just going to call the controller's key down up method and hand in the event.type and the event.keyCode, which we use to determine what the type is, whether it's a down press or an up press, and the key code is just going to determine which key on the keyboard I'm pressing. So 37, 38, and 39 are the left, up, and right arrow keys on the keyboard. So basically this controller class just gets keyboard input, and then we relay that input to the game component right here in the main.js file, inside of its update function, which is called on every frame of animation, managed by our engine, which I'm going to talk about later on in this video. So really simply, just checks to see if the left, right, and up keys are active, and then it goes ahead and it calls a player movement function. So move left, move right, or jump. So where the active value comes into play here is when the player is jumping. So notice that I'm actually setting the virtual state of the controller.up button input to false. I'm changing the active value to false. So that's going to give me the ability to press my key once and hold it down and not have my player jump again. If I were to come in and comment this line of code out like this and just go like this, comment this guy out, save my file, come over here to my browser, refresh. Now I'm just going to jump up and down continuously. Now this might be desirable for some people. For some games, this might be what you want. But for other games, you're not going to want to keep on jumping just because you have the key pressed down. So if that's something you want in your game, not having the player jump up and down continuously as your button is pressed in, this controller class right here and these button input objects here with this dual virtual and physical button state tracker objects here, these Boolean values, this is going to allow you to prevent your player from just jumping up and down continuously, and you're going to get functionality that looks like this instead. You're just going to be able to jump one time and only jump when you press the key rather than jumping just continuously if you have the key held down. Alright, so now that you know how to define the player object and the world object in our game class, and you know how to get user input to actually control this guy and move him around the screen, The only thing left is how to draw this guy. So how we're drawing the player object and the world itself to this canvas element is with the display class. So inside of the display class, I just define a buffer and a context of my canvas. So these are two 2D rendering contexts, canvas rendering contexts. Context is the rendering context of the on-screen canvas that you see on screen. Buffer is just an off-screen canvas that is going to be sized perfectly to match our world height and width. So if we come back into our game and scroll down here, the buffer canvas is going to be sized at 72 pixels high and 128 pixels wide. And that is actually going to happen all the way at the bottom of our main.js file. And the reason for that is just so everything scales the way it should. So I'm setting that up right here in the initialization portion of my main.js file. So let's get back into display and talk a little bit more about it. So I've added a couple different functions. I have the fill function or method. All it does is take a color and draw it to the buffer, which remembers the off-screen canvas, which is then drawn by the render function to our on-screen canvas. It draws this off-screen buffer canvas to the on-screen display canvas that you actually see in the browser window. So the fill method just fills the buffer with color. Render renders that buffer to the screen. Draw a rectangle just draws this rectangle here. That's what I'm handing in terms of X, Y, width, and height, and color. And it just draws that to the buffer as well. I'm actually rounding down the X and Y positions of the rectangle that I'm handing in. This way it doesn't render it on a half pixel. So let's see what happens when I take this code out. But first, let's take a look at what this guy actually looks like moving around the screen. So pretty smooth. Nothing weird going on. All the edges look pretty straight. If I come in here and I just put in X and Y though, let's take a look and see if anything changes. As you can see, it looks a little bit funky. I mean, it's hard to tell because I have this background. Let's actually go in here and change the background color of my game to something else here. Let's make it black instead. 0, 0, 0, 0, 0, 0. That's going to give me black. I'm going to come in here, refresh my screen. Take a look at the player character. You see how his edges are kind of messed up? They're kind of wavering a little bit. Kind of looks like he's just fading around instead of just sitting on the exact pixel he's meant to sit on. Well, that is actually because he's sitting on half pixels from time to time, and you can fix that by rounding down the values you pass into your draw method. So we can go from this, which looks a little bit funky, to this, which now looks really sharp and not so funky at all. It's basically the best we can get on a HTML5 canvas. So now let me set back my background color to the way it was before so we could have that nice fading effect that follows the character around. Refresh my screen. And so that's what I'm going to use to draw my rectangle to the screen and round him to the nearest full pixel location with math.floor so he doesn't get that weird blur around the edges. Now let's take a look at the main.js file, and that's where all of these are going to be called. Actually, I think inside of... Actually, no, I'm wrong. Let's just take a look at the main.js file and see where these guys are called. I think it's going to be inside of the render function. I haven't looked at this code in a little bit. So we have display.fill. And by the way, the render function is going to be called by our game engine, which is our game loop on every frame of the animation. So 30 times every second. So we call display.fill. That's going to fill our background color with this nice dark gray here. We're going to call draw rectangle and hand in the game.world.player, which is a rectangle. We're going to hand in all those values as well as the color value. And finally, we're going to call display.render. And that's going to draw the buffer that we just filled with the background color and drew the rectangle to. And we're going to draw that buffer to the final display canvas. Now, one more thing I want to talk about here, because this is pretty simple stuff, is the resize functionality. So the resize functionality is going to take care of scaling my on-screen canvas. It's also going to take care of keeping the aspect ratio of the game world, which you remember has the height and width coordinates. It's going to keep that aspect ratio from the game world and the buffer to the final display canvas, so we get a nice square rectangle every time. So What's important about that? Well, if we come down here, I told you that we're going to set our buffers, canvas, height and width to the game world height and width. Now, if I were to change this and say height times 0.5, obviously that would warp our game a little bit. So let's take a look at that and what that looks like. Oh, kind of cut off half the world, but you can see that when I jump up, the player is actually a lot taller than he is wide by about twice as much. So let's set back that back to normal and go ahead and take a look at the resize function, which I'm adding to the window that handles all of that stuff. So resize is right here. It's going to call display.resize, and it's going to hand in document.documentElement.clientWidth and client height. It's going to subtract 32 pixels from both of those to give us this nice 16 pixel margin on either side of our display canvas, which I have to refresh so it goes back to the way it's supposed to be. So that's what that's doing, those 32 pixels. And then it's going to hand in an aspect ratio of our game world, which is going to be just the height divided by the width of our game world. So now let's take a look inside of the display objects resize method and see what it's actually doing. So here I am inside of the resize method, and as you can see, it's not super complicated. It's actually pretty simple. It's basically just going to say if the height and width ratio that we handed in from document.documentElement.clientWidth and client height minus 32 pixels to give us that nice 16 pixel margin on each side. It's going to say if that ratio is greater than the height width ratio of the world object, the game world, then if the screen's height width ratio is greater than the height width ratio of the world, then we're going to set the canvas's height to the width times the ratio, and we're going to set the canvas's width to the width of the screen. So right now we have a max width scenario. Otherwise, we don't have a max width scenario. We have a max height scenario, and it's going to set the canvas's height to the max height, and it's going to set the width to the height divided by the height width ratio. So this code is basically going to allow me to do this. If I come in here and I change the scale of my window, as you can see, it's always going to keep it centered. Right now I have a max height situation and I have a shorter width in my game world, but the aspect ratio remains the same. And here I'm going to go back down somewhere around here. I'm going to change over from a max height situation to a max width situation. And now you can see my display canvas gradually getting smaller in height. So that's pretty cool. That's the display function. Takes care of resizing the canvas and maintaining that nice aspect ratio so our game can scale nicely across many different devices. All right, so now I'm going to do a brief run through of my fixed time step game engine. And this is the game engine class. It's in the engine file. I haven't changed it since part 1 of this series. It's exactly the same as it was, although I did add in this accumulated time variable definition because it wasn't in here. It was actually being added later right here. So I just fixed that, but it's basically exactly the same. So what a fixed time step game loop does is it causes your game to update and draw at a fixed rate as time passes. And it does that by taking a time step value, which in this case is going to be 1000 divided by 30. If I come over to my main.js where I actually instantiate this, I am passing 1000 divided by 30, which is roughly 33.3333 repeating forever. And that is going to be the number of milliseconds that I'm going to call render and update on. So every 33.33 milliseconds, I'm going to call render and update. And the render and update functions are just right here. You've seen them throughout this video. And they're basically just going to update my game logic and render the changed game state to the screen. Let's hop back inside of the engine and talk about this game loop some more. All right, so we've got our time step, and that's going to be, in this case, about 33.33 milliseconds. And so every 33.33 milliseconds, I'm going to call the update and render function that I passed in. They're going to be stored right here. And I'm going to keep track of how much time has passed in the accumulated time variable. So every time 33.33 milliseconds passes, hopefully our game is updating close to that. but anything that overflows is going to be stored in accumulated time. So let's say 33.33 is our minimum time step, and that's exactly what it is. But let's say request animation frame, which is what we're using to update our game logic, fires at 40 milliseconds. Now we're going to have about, what is that? 6 something, about 6 milliseconds left over, and we're going to store that in accumulated time. And when accumulated time reaches our time step, or 33.33, we're going to update or call update one more time. So basically, we're storing all the time that passes in accumulated time, and we're just taking bytes out of that accumulated time. We're taking 33 millisecond bytes out of our accumulated time. The time value is just going to be the last time our run function executes. And this is just going to be the looping function. This is going to be the function that loops over and over again. A lot of game engines will call this cycle. Some call it loop. I'm just calling my run because engines run. So this is going to be one run of the game loop. So inside of the run function, we're adding the current timestamp that's handed to us by request animation frame. We're subtracting the current time, or the last time our game executed, from the current time, and we're adding that to accumulated time. So let's say that the last time our game executed was at 100 milliseconds, and we're just now getting in a new call to the run function from request animation frame, and it's going to happen at 140 milliseconds. So we're going to have 140 milliseconds minus 100 milliseconds, and 40 milliseconds is going to go into accumulated time. So now we have 40 milliseconds in accumulated time. We're just going to set the new most recent time value to the current time value, but just remember 40 milliseconds in accumulated time. Here is where the fixed time step game loop really shines, because this, well, actually, this is just a safety I'm not going to talk about, but this is where it really shines, the while loop. So remember, we have 40 milliseconds of accumulated time, and we have our 33, I'm going to round that down to 33, our 33 milliseconds in our time step. So 40 is greater than 33. So while 40, or our accumulated time, is greater than our time step, we are going to reduce our accumulated time by the time step. We're going to call update, and we're going to set this updated flag to true, but don't worry about that too much. So then we're going to loop again and see if that's true again, and we subtracted 33 from 40, so that's going to give us 7, and 7 is no longer greater than our time step, so we're not going to update again. But let's say that accumulated time was equal to 70. Okay, so now we have 70. 70 is greater than 33, so we're going to call update. Then we're going to try to loop again. Well, 70 minus 33, what is that? 47? Is that accurate? Anyway, 47 is still going to be greater, whatever it is, it's still going to be greater than 33, so we're going to update again. So even if we didn't have another request animation frame event fire, and we didn't update the screen again, we're still going to be updating twice on the next time request animation frame fires and gives us a new run command, or we're going to call run again. So we're going to be keeping up with time no matter what happens. So even if our game runs really slow and laggy, it's still going to keep up with time, and it's going to run at the same rate basically on any device, regardless of how slow it is, unless the device is so slow that it just can't handle the game and then it will crash. But that's not something you really should worry about unless your game is crashing all devices. But if your game is just crashing the computers from 1995, then you shouldn't worry about it. But basically, the fixed time step game loop just says if too much time has passed, or if a certain amount of time has passed, we're going to update our game at whatever rate we want it to update until we have caught up with however much time has passed. And that's a really great functionality of fixed time step game loops, and it's a great reason to add them in to any game that you're writing. So now down here we have the updated flag. Basically, we turn that flag on, we set it to true anytime we do an update. And then if it is true, if we have updated, then we're going to call the render function, and that's just going to draw our game. So why is this good? Well, let's say accumulated time only has 20 milliseconds in it, but we need 33 milliseconds to justify an update. Otherwise, we'd be going faster than we want to update. Well, if that's the case, then this never fires. We never update our game. And if we don't update our game, nothing has changed. And anything we draw is just going to be a waste of CPU or GPU. So we don't want to draw anything that hasn't been updated or changed. So if no update has occurred, updated stays false, and we don't draw. And finally, inside of the run function, we just make another call to the handle run method. And the handle run method is just down here. It's just an arrow function that calls the engine.run method. Now, the reason I'm using an arrow function is because if you've worked with event listeners or request animation frame before, the this keyword inside of whatever function you hand into your event listener as your event handler, or request animation frame as your response to a request animation frame event firing, is going to point to the object that you request the frame or add an event listener to. So in this case, it's the window. So I don't want this to refer to window. I want this to refer to my actual engine object. So by using this arrow function, I can actually make this refer to my engine object rather than the window. So that's the only reason I have that kind of set up as an arrow function there, to make sure that the this keyword is referring to engine instead of window. Otherwise, I would have to have a reference to engine inside of the engine, and that just is really, it just seems really sloppy to me. So I set up the arrow function, and that's what that does. And anyway, I hope that was a good explanation of a fixed time step engine, and probably wasn't the best. I was kind of going through it really fast. It's really cold in this room where I'm recording, and I'm like freezing to death. So don't hold it against me. I should turn up the heat, but just I'm doing what I'm doing here. So hopefully that was a good enough explanation of a fixed time step game loop. And if not, definitely take a look at the source code. I commented everything in here so you guys can get a better understanding of the code as you read through it line by line. In this video, I showed you how to lay the groundwork for any platforming game. So far, I've implemented keyboard input, simple platforming physics, scaling for multiple devices, and a fixed time step game loop to handle updating your game at a consistent rate no matter what device it's on, which is perhaps the most important thing you could take away from this video. If you want to learn more about this example, check out the source code and working example that I have linked in the video description. And if you want to see more, subscribe to my channel and I'll keep the code coming. Until then, thanks for watching and have a good one.